will be happen if you choose to deal with all the whole element of the population. So, what is the sampling process? What are the major steps in sampling? What are the steps that we should go through to take sample of population? Here are some steps. First one is to define the population. Who are your population? Decide about your population. Okay? It depends on your topic. Determine the sample frame. Means the sample characteristics. What should be the sample characteristics? How should we define this sample? What are the limits of this sample? Determine the sampling design. How to design, we are going to design this sample. Determine the appropriate sample size, how to choose the size. And we say there are some hints, some criteria that we will see after this that can give some information about the sample of size, or as we said through the literature, execute. The last one is execute the sampling process, means actual selection of people, which is the execute.
Please, Dr. What about sampling design?
Sampling design means how to make the limits of this sampling. Means, okay,
boundaries.
What are the properties of people that should be selected for this design? And understand or study maybe the characteristics of those people in order to design the sample that reflect the whole population. After this, we will see what we mean by this through understanding the homogeneity and heterogeneity. The elements inside the sample itself should be homogeneous. Yes, but the elements among different samples should be heterogeneous. And we will see what are the ways or the approaches that will be used for sampling. Sampling techniques. What are the techniques used for sampling? Generally, we have probability and non-probability. Probability versus non-probability sampling. Probability sampling, elements in the population have a known and non-zero chance of being chosen. So we are not selecting them just by random selection or just by dividing. There is what we call chance of being chosen. This is probability. What is the chance of selecting you among the CGS students?
The same.
It could be the same, it could be different. If there are some other criteria.
But it's not zero.
It's not zero, yes. Known and non-zero. So we can calculate this chance or this probability, and this probability cannot be zero. So this is the main probability sampling. We said sampling can be probability or non-probability, probabilistic or non-probabilistic. The probabilistic elements in the population have a known and non-zero chance of being selected. Probability sampling involves simple random sampling, systematic sampling, stratified random sampling, clustered sampling. The non-probability sampling involves convenience sampling, judgment sampling, and quota sampling. Okay? Most likely we are using probability sampling. Most of our researches depends on the probability. It's not depends on judgment or quota. I think in human sciences, They don't care about probabilities. They sometimes, I mean, most of the times in the human or humanity sciences, they are based on judgment because they cannot specify some things in. They don't have precision in selecting or in judging. So they are not objective, they are subjective. But in our topics, most of the scientific topics are objective and we are dealing with probability sampling. The first one, which is simple random sampling, what do we mean by it? The procedure, each element has a known and equal chance of being selected. This is the very easiest one. Simple random sampling. Okay? Each element has a known and equal chance of being selected. So there is none of the elements is preferred than other elements.
There is no equal chance.
Yes, there is no exception.
All of them
The whole
equal chance.
have the equal chance. So, and this chance also can be determined, is known. It depends on the number of elements and these things. We can calculate. So we can calculate the probability of selecting any of the elements equally. Okay? So what are the characteristics? Highly generalizable. In this way you can generalize. If you choose your sample, in this way you can generalize. Why? Because all of them are the same. So the result on selecting some of them could be generalized because there is no preference for some elements on other elements. If there is a preference on some elements on other compared to other elements, and then your result will be biased through the preference for the thing that you preferred. Okay? But since they have equal chances, equal probabilities, so your result can be generalized easily. And also it's easily understood. You can understand it very easy. And reliable population is necessary. In this way, your population frame should be reliable. Okay? Why? Because you are selecting randomly. So everything inside this frame should be reliable, should reflect this population. Shouldn't be outlier or something that deviates from the characteristics of the population. Okay? The second one is a systematic sampling. Procedure, how we are going to do it. Each n element starting with random choice of an element between 1 and n. So here also we have random choice of element. But here we have boundaries, n elements. Each n element, the nth element, starting with random choice, we are choosing random between 1 and n. N is determined, is predetermined. Okay? The design of this kind of sampling, we give the n, which is a number of elements. And we are going to choose randomly, but between 1 and n. Characteristics is simple. This idiom is simple random sampling. It's like the simple random sampling. Okay? Easier than simple random sampling. Why? Because it determines the borders of the sample. So it's easy. Systematic biases when elements are not randomly listed. If the number themselves are not randomly listed inside the sample, it will go, it can happen, this kind of systematic biasing. Hello.